Where are we and what are we doing?
We are out in the field and we're going to launch a rocket.
Do you remember what the kind of rocket it is? What are you wearing?
Safety goggles,
Why is safety goggles important?
so the water doesn't spray into our eyes.
What fits off the rocket and actually your eyes?
Yeah.
Do you find these goggles to be the right size for you?
Well, they're a bit too big for me.
They're still
The right size.
I like how it goes over your hat. That's
I'm taking one of keep my hand above them.
okay. And of course, little one here has it's about to have her goggles adapted as well, which I think will be the cutest thing in the world ever.
Yes.
Wow. Okay. So, how does the rocket launch work again?
So we're going to put some water in our rocket, then
Safety adjustments, yeah.
Then we're going to put it on the stand, and we're going to pump the stand up. Then we're going to let it launch.
Okay, what do you think is going to happen? Which direction will it go in?
It's going to go that way because of the wind.
Do you think? Okay. Right, what we'll do is we'll do a couple of launches. We've got right enough water for 3 launches, I think. See if it doesn't explode or die in the meantime. It's a little bit windy. We're on this bit of land, very beautiful scenery. And we're launching here. The wind will blow us away from the field, and we won't get enough height to actually be able to hit the houses way over there.
10, 20, 12, G. The launch was a successful career. The rocket went a long way away. Launch to 10:35. The launch was a successful succeed. The rocket spun round 3 times after launch. The last one. The rocket shot into the sky.
Yeah.
Let's go.
So before we start the fun science bit, I just want to talk for a second about safety. The question is, why am I holding this by hand rather than using the release mechanism that we had built here? Well, whilst the release mechanism works fine, it didn't actually work as a seal. Pumping air in just pumped water out, and when I pressure tested the rockets in the back garden, I had jammed the rockets into my workbench so it couldn't fly. I didn't realise this was holding them to the seal. Because of this, I was only taking the pressure to much lower levels than I knew the bottle would take. That was comfortable to hold in the bottle at. The other effect was at much lower heights, but with the wind that we had, it was good. The problem with holding it this was 1, I think I was affecting the launch, especially the second launch, and 2, I wasted water by a false launch here on the 3rd launch. So next time you should see an improved seal and us using the trigger with a string to launch it from further back. The other lesson that we learnt quickly was that the video recording was harder. To quote my wife, it went off faster than I thought. Like a rocket perhaps. Well, let's work out how fast it did go off. These few frames are from the iPhone. The phone is recording at 30 frames a second, and let's ignore the technology issues and assume they are perfect snapshots, 1/30 of a second apart. If you notice, the flow of water changes suddenly. This is because all the water has been expelled, and it's just a mist of air blasting the last few drops out, so we can assume that the acceleration has finished by this time. I won't go into detailed maths in this first video, that's for Mini later on, but it seems the acceleration is over by the 1/10 of a second. Looking at the high speed camera, we get 17 frames before it goes out of shot. This is at 240 frames per second, so it's less than half the time till the bottle is empty. Better camera mounts needed rather than propping up in the field. I think this is over so fast because there isn't enough water in the bottle. Most was lost going into the launcher and by the not great seal that we had. So lots to learn and plan for next time. Better nose cones, more water, better releases and better footage. In between launches, Minnie took some notes for later, and a great day was had by all.